Hey everybody. Today we're going to be looking at specific examples on how to find angle measures given two sides of a right triangle. I've listed about 6 conceptual steps that we need to take a look at, okay? Whenever we're working on these types of problems, the first thing you want to do is locate the angle in question. Then you want to label the sides appropriately: hypotenuse, opposite, and adjacent. After that, you want to use SOHCAHTOA to identify which of the ratios to use. Is it the sine, which is opposite over hypotenuse? Is it the cosine, which is adjacent hypotenuse? Or is it the tangent, which is the opposite over the adjacent? Okay. Once you've done that, you want to write out and substitute the values for the two given sides of the triangle. Following that, you want to use the anti. Okay, this is a word that it's kind of nice to use here, like the anti-something. Okay, it's also named as an inverse or an arc, and in here I'll show you that I'm talking about arcs. Okay, so these are all parts of the trigonometric function to isolate the angle. Okay, make sure to do this to both sides. So we're going to look at these right now. The arc sine is sine to the -1, the arc cosine is cosine to the -1, and the arc tan is tan to the -1. Remember to hit the second button, the second function button, the blue button, right? Second button, it's right underneath y equals, before hitting the trig, sine, cosine, or tangent to activate their anti-cosine, sine, and tangent. So, in other words, the arc sine is like the anti-sine. The arc cosine is like the anti-cosine. And the arc tan is the anti-tan. Okay? So, make sure that your calculator is input correctly and make sure it's in degree mode. So the first example we have here is to find the value for alpha in degrees. Okay, and right now we're always going to be talking in degrees, but I figured I'd specify it. So I drew out a right triangle, and we've noticed that we have the opposites and the hypotenuse. Okay, so I went ahead and labeled those appropriately: opposite, hypotenuse, and then I went and did what was suggested in conceptual steps. I took the sine, right, because it dealt with opposite and hypotenuse, and then all I did was substitute the opposite and the hypotenuse. Then took the anti-sine, if you will. If that helps you remember how to do this, that's okay for right now, okay? But so we're taking the arc sine of the sine, so those are inverses. They cancel each other out, in other words. So they'll basically do this. They'll cancel each other out on that left-hand side, leaving just alpha. When you run through the calculator and you type in second sine and then 1 over 2, you're going to get 30 degrees. And remember, it's one of the things I did tell you before. One of the things that you really, really should know is the sine of 30 is a half. Okay? Notice that's a interesting special right triangle. Example 2, find theta. Find theta. Whoa, well, find theta seems pretty interesting right here. We got an opposite side of 5 root 3, and we have adjacent side of 5. So if you're really quick, maybe you figured out what the angle is already. But just in case, we're going to use the trig ratios this time. And see what we did here. We took the tangent, which is the opposite over adjacent. I then simplified because the two 5s will cancel out or become a factor of 1, right? 5 over 5 is a factor of 1. So it becomes tangent of theta equals the square root of 3. Now, if you remember from one of our previous videos, you should know what that is, and that's 60 degrees. But remember, we're taking, if you want to think of it this way, it might help you. The antitangent of the tangent of the angle, okay? At this level, I hope that makes a lot of sense. You're taking the anti-something of the angle. So those two will cancel out, if you will. Okay? Now, did you know the angle measures already? Were you able to recall the patterns for the two special right triangles? And just as a reminder, we are spiral learning. Woohoo! Spiral! Okay, that was enough of that. Okay, so example 3. Find the angle of depression. So I called it beta sub d. And I kind of took like a basic example of maybe a plane flying at normal altitude and LiDAR hitting the ground. And maybe what's going on down in the ground over here is they're looking at the old remnants of an old village that used to be there, and they can see the old foundations and what it looked like. Whoops. Maybe it looked like that. I don't know. But you could actually see the old foundations, the old building structures underneath the ground using this type of technology. So what would the angle of depression actually have to be if the LiDAR had to be 13.5 miles away from the target, which is the plane? Well, that's the plane right up here. Plane's flying along, but we stop time. Everything's frozen in place. So how do we work out the problem? Well, there are a lot of ways you could have done it. You could have used, if you were thinking about it, alternate interior, because there's two parallels and there's a transversal. That's one way. So you know that BD is also down here if you did it that way. But I did it with a regular triangle, and notice I just made my new triangle like that, right? It's still the same triangle. It's just reversed almost, if you will, right? So I know nothing about the horizontal distance I am at. I do know that I'm at an altitude of 7 miles. I'm 7 miles up. And we know that the LiDAR has to work at 13.5 miles for some reason, okay? Just basic example. So you'll notice I labeled the sides accordingly. Hypotenuse first, opposite, and adjacent. Now, when I did this, it was easy to see that we were going to use the sine, and we went through the same basic process as before. The big idea here was to set up a new triangle that would help you. See, sometimes we kind of have to come up with things like this, right? Where we're going to have to create based on what we have, okay? And that's one of the key instructions to remembering how to solve these types of problems, okay? Because you might be saying, well, how do I figure this out if I don't know? If I don't know, like, for example, this angle. What's this angle? Wait, what's this angle? I don't know either one of them. I don't really know any of the angles. But if I knew one of these angles on the inside of the triangle, then I could work with the trigonometric ratios. So I am just showing an alternative way to solving one of these types of problems. So I kind of hope this helps a bit. Please let me know. And look forward to seeing you in class. Have fun. Bye.